In this lesson, we will calculate pKa and pKb values and see how to rank acids and bases in order of strength based on those values. Just as we use K for the equilibrium constant for a reaction, K is also used here as an equilibrium constant. We use the subscript A to indicate it's the equilibrium constant for an acid. For the reaction HA going to H plus and A minus, we can write the equilibrium expression as H plus times A minus over HA. We add the subscript A to indicate we are talking about the equilibrium constant for an acid, but the formula is still the same. Remember that P of any value is equal to the negative log of that value. If we have the Ka of an acid, which gives us something about its equilibrium constant, we can find the pKa by taking the negative log of Ka. Likewise, if we have the pKa value, 10 to the minus pKa will give us the Ka value. Let's look at some examples of weak acids. Here we have 5 weak acids and their corresponding Ka values, which are reference values. The first thing we want to look at is how to get the pKa value. pKa is equal to the negative log of Ka. So the negative log of 7.1 times 10 to the minus 4th is equal to 3.15. Next, we'll find the pKa value for HNO2, which has a Ka value of 4.5 times 10 to the minus 4th. Negative log of 4.5 times 10 to the minus 4th is equal to 3.35. If we continue this process, we can find pKa values for every Ka value. The value of the Ka and pKa give us information about the strength of the acid. In order to compare Ka values, we need to be able to compare the magnitude of those. Sometimes it's harder to see what those values are when looking at the numbers in scientific notation, so we're going to rewrite them in standard notation. 7.1 times 10 to the minus 4th is 0.00071. 4.5 times 10 to the minus 4th is 0.00045. And we can continue for the other values. Now it will be easier to compare the magnitude of these numbers. While strong acids dissociate completely, weak acids partially dissociate. As a result, they dissociate in different amounts, so every weak acid has a different strength from other acids. When we look at Ka values, what we see is that the larger the Ka value, the stronger the acid. So as Ka increases, the acid strength also increases. The smaller the pKa value, the stronger the acid. So as pKa decreases, the acid strength increases. Remember our Ka expression. As an acid gets stronger, we see more dissociation of the acid molecules into ions. The Ka expression includes the ions or the products in the numerator, so the larger the numerator and the smaller the denominator, the larger the Ka value. Just as we looked at weak acids, we can also look at the relative strengths of weak bases. Instead of having Ka values and pKa values as we do for acids, we have Kb and pKb values for bases. The equilibrium expression looks the same. It's still products over reactants. We're just using the subscript of a B to stand for a base. The larger the Kb value, the stronger the base. So as Kb increases, the base strength also increases. As pKb decreases, the base strength increases.